Okay, I have hit the timer. Let's get started on this one. This is P1 January 2015. Okay, I'm just going to scroll down here. Number one, we have to integrate this whole thing. So I guess that's not hard. I'm going to use blue pen here. Integrating the first term. So this is basically power rule straight, right? We can just adjust the constant so that it's easier to look. So the square root x here is x to the power of a half. And this is basically 2 over 5, x to the power of minus 3. All right, so we integrate this. Don't forget to write the x at the end. Some people do forget that. So this is equal to, integrating x to the 3, we get x to the 4, divide by 4 here. I shouldn't write that. And then integrating x to the half, we get x to the 3 over 2, because that's adding 1, divided by 3 over 2. Integrating x to the minus 3, we get x to the minus 2, dividing by minus 2. And don't forget the plus c. Right, so we're just going to simplify this. So 4 canceling 8, we get 2x to the 4. This is 3 canceling, and times 2, we get 4x to the 3 over 2. And this minus minus becomes a plus. So this is 1 over 5, x to the minus 2 plus c. That is question 1 done. Easy peasy. Okay, so next one we have, I'm just going to open the question here as well and zoom into this. Okay, so next one we have question 2, given that the point, let me just adjust my camera a bit, hang on, because this is too much Chrome key. Okay, I can afford some time here, don't worry. Okay, yeah, I think my hair is getting better there, don't I? Yeah. Okay, I think this is done. All right, sorry about that. Okay, so question 2a. Show that the gradient L1 is P3, where P is the rational constant to be found. You must show each step of your working. So we have point A and point B, and the line L1 passes through. So we're going to find the gradient first, and that's just by y2 minus y1 divided by x2 minus x1, right? Delta y over delta x. And we're just going to take the point from B to B2, so that's 8. The point from A to B1, so that's 5, yeah? And x2 would be 7 root 3 from the B, and x1 would be minus 2 root 3. So that simplifies to 3 over 7 add 2 is 9 root 3. Or, the 3 canceling 9, we get 1 over 3 root 3. So that's fine. We're just going to keep it like that first. Don't need to simplify yet. And oh, that's already the gradient. So the gradient of L1 is that. But if we want to simplify, we can multiply that by root 3 over root 3. So we get root 3 over 9 down here. And that is just 1 over 9 root 3 as required, right? So we have shown that it is P times 1 root 3. So 1 over 9 is the P in this case. Okay, so question B. Straight line L2 is perpendicular to L1 and passes through A. So M of L2 would just be minus 1 divided by the M of L1, which is 1 over 9 root 3. So if we do the thing there, we would get minus 9 over root 3 here. Or simply just minus 3 root 3. If you put that in the calculator, it should simplify it for you. I'm just thinking of this by myself. So there you go. And it passes point A. So we're just going to use y minus y1 equals mx minus x1, yeah? So y, we don't do anything to y, we just write y. y1, we're going to just take the y coordinate of A, which is 5. M is just 3 root 3. X minus x1 is the x coordinate of A because it is minus, so we do plus here. Okay, so that's it. So what is this? If we multiply everything through, we should make y the subject as well because this is y equals mx plus c. So I'm just going to move 5 later on there. okay, x. And then if you multiply minus 3 root 3 into the 2 root 3, you get minus 6 times 3, which is minus 18. Yeah, just multiply those through. And then minus 5, you add 5 from the other side. So the equation becomes that minus 13, right? So that's done. Okay. I forgot to record my calculator as well in case I use it. So m and c are constant. So I think I'm done with that. Yeah. Okay, let me just hang on. I have something to do with my air purifier. It's being loud right now. Just gonna close it or something. Okay, here we go. Just in case. All right. Next, number 3. We still have time, of course. Just gonna do number 3 there. Okay. A. Number 3, the population of a town was monitored. Exactly 5 years after monitoring began, the population was that. Exactly 10 years becomes that. Given that the population of town, P,000, we got to be careful with that. All right. So like 58,000, we have to change that to 58. This is where most people might go wrong here. T years after monitoring began, it can be modeled by that equation. All right. So find the value of A and the value of B. So we just plug in the equation. So for the first case, when P equals 58, not 58,000, because P is in thousands here. 58 to the 2 equals A plus B. T is year, so that's 5 squared. Sorry, cubed. All right, so that's just the first equation. The second equation, I already put in 65 squared equals A plus B, and this is 10 years as well. Seems like if I do 2 minus 1, so let's say this is equation 2, this is equation 1. If I do 2 minus 1, it would be a bit wiser because we have positive constants. So this is 65 squared minus 58 squared equals, A would cancel. Then we would have here, if I factorize B out, so it would be 10 to the 3 minus 10 to the 3b minus 5 to the 3b, right? So it's 10 to the 3 minus 5 to the 3, and all multiplied b. I just factored b out, if you can imagine that. So b in this case would be, you can just do, okay, let me show in the calculator. So we just move the brackets down to divide. We have 65 squared minus 58 squared, and all, hang on, that's bad. Gotta do that again, hang on. 65 squared minus 58 squared. All that divided by 10 cubed minus 5 cubed. And that is a nice constant. It seems like a nice number there. That's B. Okay. And then we find A. So we just plug B into one of the equations. I'll just go with 1. So A would have to be, using 1, 58 squared minus B, which is that guy, times 5 to the 3. Okay, so I'm just going to do answer here, and 58 squared minus answer, which is B we just found, times 3 to the 5 to the 3. So that is exactly 3241. And that is the answer for A. For B, according to the model, exactly T years after monitoring began, the population was that. Making your method clear, well, we just use the equation we just found for A and B. So we put 85 squared here because, again, P is in thousands, equals A is, again, 3241, plus B is, again, 0.984, times T here would be the big T they want, cubed. So T is just equal to, well, we just rearrange the equation, and when we do cube root after everything, so it's going to be 85 squared minus that first, just solving the equation, and all that divided by 0.984. So this is cube root, fraction, 85 squared minus 3241 divided by 0.984. And I should get about 15.9382 blah blah blah, and they want the answer in 1 decimal places, 1 decimal place, so which is equal to just 1 decimal place, 15.9 years. Then that's my answer there, and that is done. So next question, question 4. I'm gonna be quite sharp on this paper here because I don't have fully an hour and a half. So guys, this is an easy paper anyway, so I hope that's fine by you guys. Question 4, I and then a here. Given that y equals a to the x, where a is a positive constant, that's fine. Expressed in simplest form in terms of y and a to the 3x plus 1. All right. So a to the 3x plus 1 is a to the 3x times a to the 1, which is a. Okay? A to the 3x, well, because they have a to the x for us, so we do a to the x and then to the power of 3 after that. Yeah? And then times a. So a to the x is y to the 3, and a we can keep it because they allow a here in the expression. So that's done for a. For b, a little bit more complicated. So if we just move everything in the denominator, yeah, up, so that's going to be just 5 times everything that they have to the power of 2, simply that. Now let's do something with that to simplify. So this is, if I distribute the power here, I get 3 to the 2, which is 9. Yeah. And then that would be a to the 2 minus 2x. All right. We just distribute the power in using a law of index. So we have 45 here, 5 times 9. And a to the 2 is just, we split using another law of indices. And this is a to the minus 2x, right? Just splitting them up. So this is 45a to the 2. And, we can use a similar approach here from the part A. So this would become a to the x and then to the minus 2. All right, that still works. So we would have for that 45a squared. A to the x again is y. So this is y to the minus 2. So I can write over y squared here as well. If it's to the minus, then we can make it positive by bringing it down to the denominator. And that is my answer then. Okay? Now, next part, the second part. Use the substitution p equals 9 to the t to show that equation that can be written as that. All right. So let me just zoom in the question a little more here. Okay. So we have p equals 9 to the t. Okay. Yeah, I'm just going to expand the left side. So we have 3, because 3 is multiplying into the first part, 3 to the 4t plus 2. So that would become 3 to the 4t plus 3, because there's another 3 multiplying with it. Okay, it's like you adding another power there. And this part is also a 3, because you're multiplying in. And what about this? This is 82. So we have 82p, I guess. Yeah, we can change that already. Now, what about this, right? So we simplify a little bit. So we have, okay, let me think about that. So 3 to the 4t times 3 to the 3 here. Okay, plus 3 equals 82p. So I'm just using a law of indices to split the powers like this. And 3 to the 3 is 27. Now 3 to the 4t, we can do something to get the 9 to the t there. So 3 to the 4t is 9 to the 2t, right? It's just splitting the power of 4 to 2x times 2, and then you just put it's like this, yeah? Right? So if you try inspect backwards, you get 3 to the 4t. So the 3 to the 2 here becomes the 9, right? Okay. And then I have minus 82p plus 3 equals 0. Just tidying up there. Okay. So I think this is it. 9 to the 2t is the same as 9 to the 2 and then to the power of t. So I'm just going to write that already. Sorry. 9 to the t and then to the power of 2. Okay, so that is p squared, basically. So 27p squared minus 82p plus 3 equals 0, as required. Okay, so that's the part A bit, and part B down here, maybe. Hence, solve that. Well, we are not going to solve that exact equation. We're going to solve our equation here. So, let me think about that. I'm guessing we can factorize because I don't have an advanced calculator that can solve quadratic. So I'm just going to go by myself. Let me think. Okay, I think 3 and 1 works. So I'm just going to do that. Yeah, so 3 times 27 is 81. So 81 and 1 makes it 82. So here we have p equals 1 over 27 or 3. Okay, that means we're going to split now. P equals 21 over 27 or P equals 3 because we let P earlier be 9 to the T. So I'm just going to write that. So for the first case, we have 3 to the 2T equals 3 to the minus 3. Yeah, just happen to know that. Yeah, this is 3 to the 3 down here using a law of indices. You bring the power up here to be a negative. So that means T here would be minus 3 over 2. You equate the powers and then you would get T that value. Okay. Or we also have here 9 to the T equals 3. Again, 3 to the 2T equals 3 to the 1. So we have T being equal to 1 over 2. Okay, so that's it. That's the answer there. Two answers for T. Okay. Next question, number 5, right? Okay, number 5 right here. I'm just going to do this blank space here. Part A. Find dy by dx, giving your answer in simplest form. Okay, that's simple. So let's simplify y a little bit. So we do 4x to the 3 plus 2 to the 2 times x to the minus 1. Okay, and then plus 9. Yeah, that's just simply the first step usually. And then when we do dy by dx, we use the power rule for differentiation. So we subtract the power by 1 and then we bring the power down. Sorry, we bring the power down to multiply first, we get 12, and then we minus the power by 1, so we get x to the 2. Okay, again, bring the power down to multiply, we get minus 2. Minus the power by 1, we get minus 2. And 9 basically differentiated to get 0. So that's done for the first part. Simplifying in the simplest form, well, I think maybe we can do something like if we bring x to the minus 2 out and 2 as well here. You know what, I'm just going to write 12x squared minus 2 over x squared like that. That's the answer. Okay. So B, given that the point P lies on C, the line with equation that, where K is a constant, is the tangent to C at P. Okay. Show that the x-coordinate of P satisfies the equation. So we know that the gradient of tangent is minus 5 because it's just in front of the x. It's minus 5. So we equate minus 5 to the derivative of the C function, which is this guy that we got earlier. So we do minus, I'm just going to do 12x squared minus 2 over x squared equals minus 5, yeah? So let's multiply x squared across. We get 12x to the 4. And then this is minus 2. But because I know that I got to move this to the middle term anyway, so this is 5x squared as well. I move to the left, I get plus 5x squared here. All right, so that's just simplifying the quadratic there, kind of. It's not exactly quadratic, but we can solve quadratically by letting x squared be something. Right? But that's already done. That's already what we want in B, yeah? Now C, we're going to solve that. So solve for K. So let's solve that. We can put, let's see if we can factorize. Like, if you guys are familiar with the technique, let Y or another letter maybe, because we already use Y here, maybe let T be x squared. then that would become t squared, 12t squared plus 5t minus 2 equals 0, and you solve quadratically. But I'm just going to do this. I would like to factorize as well, so I do 4x squared and maybe 3x squared here. I'm just guessing, you know. So let me do 2 and 1. Does it work? 2 and 1. Yeah. 2 here, 1 here, and plus here, minus here. Yeah, so that works. So I get 3x squared here and minus 8x squared. Oh, no. So it should be a plus here and minus here. So that's 8, and minus 3 becomes 5, and everything else works. So I get 4x squared minus 1 equals 0 here, or 3x squared plus 2 equals 0. So this would be x squared equals minus 2 over 3. We know that that is impossible, so no solution. Okay? No solution for that. So I ignore that part. I'm going to solve for this. So x squared equals 1/4. That means x equals plus or minus 1 over 2. Right? Now, because I just glanced the question again, I get 2 solutions. I always check. I'm always be careful here. I'm always careful. So if you look at the first line of the question with the equation, because x greater than 0, therefore x must only be a half. Okay? So we get the x coordinate of point P. This is just the x coordinate of point P. We're not done. So we know the x coordinate of point P, right? And because we want to know what k is, we need to know the y value of the point P as well. So y value of point P is just done by substituting in the curve equation, because this point is also on the curve apart from the line. Yeah. So we do 4 and then a half subbed in, we get that. Okay. Okay, so a half cubed, we get 1 over 8, so that's a quarter. This is 2 over a half, which is 4, and plus 9. So that's 13 and a half. I'm just going to put 13.5. This is 0.5, okay? So we're going to use the equation, the tangent equation. So y is 13.5 equal k minus 5 times 0.5. So k would be 13.5 plus 2.5 there, 5 times 0.5. So this is 16 basically. Okay, I'm done with that, I think. Here we go. So we do question 6 now. Okay. Question 6, yeah? Okay, 6a. The curve has equation that, given the point P, 4 minus 5 lies on C. Given that f dash x is that, the gradient of tangent to C at P is 7. Okay. So note that we got to be careful. Don't go autopilot. We already have the derivative function, which is f dash x. That is dy by dx, guys. So that means if we substitute x equals the x coordinate of P, which is 4, we're going to get the gradient of the tangent to point to curve C at P. Okay, so we do f prime sub in 4, which should be 7, okay, because they're giving us 7, equals sub in x as 4 squared plus 4a here, and plus b, because we don't know what a and b are yet. And then 4 sub in x, we have, what's x again? 4, yeah? So we have one equation here right now. So this is 8, yeah, 8 down here, times 7, we get 56 up here. And then this is 16 times 2, 32, plus 4a plus b. And I'm just going to simplify. 4a plus b equals, subtracting the other side, we get 24. All right, so that is just, oh, I already got that. Okay, yeah, it asks you to prove that. That's fine. And then for b, given also that a plus b equals minus 9, we're just going to solve, right? Okay, so, yeah, so 4a plus b equals 24. And then you have a plus b equals minus 9. I'm just going to simply subtract them. So I get 4a minus a being 3a, B cancels away. 24 minus 9, I get 33. So A would become 11. And then B would become subbing A 11 into this simple equation. 11 here got subtracted both sides. We would get B equals minus 20. So that's A and that is B. Oh, not yet. We need to simplify the fx. Okay, we're not done, basically. So fx is found by integrating the first derivative, yeah? Okay, so we're going to integrate that gradient function there. Okay, so let's simplify the integrand first, because that's a big fraction. So it's 2x squared over 4 root x. I'm just going to split the fraction to partial fractions. A is 11, so we plus 11x divided by 4 root x as well. And B is minus 20, so we minus 20 divided by 4 root x, the x here, brackets. I always put brackets with the integrand, okay? Just going to carry down here. You simplify the first term, you get a half for 2 and 4, and then this is 2, the power is 2, so minus a half, so you get 3 over 2, so that x 3 over 2, like that. Okay. Plus 11 over 4, and then this is x to the half, right? 1 minus a half. 4 cancel 20, we get 5, and that x to the minus 1/2, yeah? Because it's over root x there. Okay. So I'm just going to carry that down here. Okay, integrating x to the 3 over 2 plus the power by 1, we get 5 over 2. And 5 over 2, so we multiply 2 over 5. It's just the opposite when we bring it up, yeah? The power added 1 here, you get 3 over 2 for that. So that's times 2 over 3. Okay? Added 1 here, you get 1 over 2. So that's 5 times 2 over 1. X to the half. Because we don't know what c is yet, we do plus c. Because this is indefinite integration. All right? So simplifying everything, we have fx here being equal to 1 over 5 x to the 5 over 2 plus, that cancels to be 11 over 6 x to the 3 over 2 minus 10 x to the 1/2 plus c. Now, because we know that the curve passes point P, so we can sub point P in again. So we do minus 5 here equals 1 over 5 sub in 4 to the 5 over 2 plus 11 over 6 sub in 4 to the 3 over 2 minus 10 sub in 4 to the 1 over 2 plus c. And that is where we're going to calculate c, yeah? So I'm just going to do, okay, so this is 2 to the 5. So that I'm just going to move everything here to the other side. So minus 5. This is 2 to the 5, guys. So it's 32. So minus 32 over 5 plus. This is 2 to the 3. So it's 8. So it's minus on the other side, minus 88 over 6. Yeah. Just mentally calculating it here. Yeah. And then because this is minus, so this is plus 20. Okay, I'm guessing I'm using a calculator now just to be safe. Minus 5 minus 32 over 5. Minus 88 over 6. And then plus 20. Ooh, that's... okay, I get a fraction here. Minus 91 over 15, right. So, yeah, in a simplest form, so we have fx equals 1 over 5 x to the power of 5 over 2 plus 11 over 6 x to the 3 over 2 minus 10 x to the 1/2 minus 91 over 15. I guess that's simplified enough. And then we're going to do c. Curve c is transformed to the curve with equation that. So this is shifting to the right by 3 units. Given that point P transformed to the point Q, state the coordinates of Q. Well, P is 4 minus 5 again, transform to Q, so it's just shifting right by 3 units. So we get point Q shifting right, which means X will be added by 3, so that's 7. The Y remains the same, so we get that. That is the coordinates of Q, all right? Okay, next, number 7 here. Okay, I'm just gonna go down here too. Oh, we need to sketch first, so this space to sketch. The curve C has equation that where K is a positive constant. Okay, sketch the graph of C. All right, so this is a rectangular hyperbola. So you got to know that y equals 1 over x looks something like that, right? Kind of. So that means this is 2 over x is going to be just more steep than this one, but you bring the graph down. So instead of being that with the asymptote of the x and the y-axis, now the horizontal asymptote will be shifting down by k. So I'm just going to do dot, 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 dot here. And this is y equals k, shifting down because k is a positive constant. Let's make that a little smaller down here. Sorry, k. No, minus k, I mean, yeah. And then you're going to get this kind of curve, right? And this kind of curve. Okay, like that. We should show on the sketch the coordinates of any points of intersection of C with coordinate axes. At least there is one here, right? So this is where y goes 0. So y goes 0, we can solve for x in terms of k. So x would be moving k to this side, switching the term, we get 2 over k. You can just try that by yourself. So we have 2 over k right here, okay, for this. And then the equation of horizontal asymptote, we already have that. Y equals minus k. Okay, each term in terms of k. So we're done here, A. Now B, down here maybe. The line L has equation y equals minus kx minus 6. Given that L intersects C at 2 distinct points. Right, so this is discriminant. Okay, so we're going to equate them. So we have minus kx, which is the y of the line, equals 2 over x minus k, which is the y of the curve. We equate them, we solve. And we say that there are 2 distinct points, so discriminant will be greater than 0. I'm just multiplying x across here. I get minus kx squared minus 6x equals 2 minus kx, yeah? Just the first step. And then we can rearrange here. So we just move k to add with the minus 6, so we get plus. I guess we can do k minus 6 here with the x factored out, and then minus 2, don't forget. Okay. So because there are 2 distinct solutions, as there are 2 intersects, so we do b squared minus 4ac greater than 0. And then we're going to solve for k, the range. So here, b squared minus 4ac greater than 0. Right? Just comparing the coefficients there. So this is expanding the binomial here, k squared minus 12k plus 36 quickly for this whole thing. And there are 3 minuses here, so this is 8k, minus 8k, yeah? Greater than 0. So I'm just going to tidy up that. I'm going to get minus 20k plus 36 greater than 0. Seems like we can do 2 and 18. So I do k minus 18 times k minus 2 greater than 0. Just factorizing it manually. So that means the answer should be, when you have a greater than sign, the ranges will diverge from 2 to 18. So what I mean by that is basically you get x greater than 18 or, sorry, k greater than 18 or k less than 2, right? And I think that's it. That has to be it. Yeah, so that's the answer there. Cool. Number 8 now. That's number 8, the whole question there. That's a big question. Let's see what we got here. Figure 1 shows a sketch of a design for a batch. The design consists of a triangle OAB joined and a sector OBC. Sector OBC there. Of a circle with center O. In the design, OB is 3.4, that's the radius. AB is 1.9, that's just one side. Angle AOB is pi over 6. Angle OAB is greater than pi over 2. Interesting. OAB, all right. Okay, let's have a crack on this triangle because this is quite rare. So when this is pi over 6 and this is greater than pi over 2, right? So that means this angle is less than, so if this is pi over 2, let's say if it's 90 degrees, this would be, okay, pi over 6 is the same as 30 degrees. So if we assume that this is a right angle, just the critical value there, this would be 60 degrees. So that means this must be less than 60 degrees, and in radians, that is pi over 3. So just noting that this angle is less than pi over 3. That's BOA here, right? Making your method clear. Yeah, I think that's right. A, find the size of angle OAB. Okay, so just the angle we want. We can use sine rule, right? So 3.4, sorry, this is question A. 3.4 over sine of angle A, which is the angle we want, equals 1.9 over sine of angle pi over 6, right? Yeah. So A here, if you rearrange everything, I'm going to do arc sine here, and you multiply 3.4 with sine pi over 6. Sine pi over 6 happens to be sine 30, which is 1 over 2, and divided by 1 over 9. You should try this if you don't agree with the derivation here. Okay, so angle A, I'm going to do arc sine, and the answer should be in radians. So radian here already, so arc sine fraction for 3.4 times 0.5, because that's a half, and that. So this is OAB angle is equal to 1.108 to 4 significant figures. I'm going to do 784 ... first, and I'm going to just conclude that it is that, the 4 significant figures. All right. And then we find the area of triangle OAB. Okay. So the way we find the area is that we can use the angle OBA, right? Because we already know the sides of this guy and this guy, right? So let me draw a new triangle down here. Okay, so we know that this is 1.9 and this is 3.4, and that's the angle we want to calculate the area. This angle right here is going to be 2 pi, sorry, not 2 pi, just pi, which is 180, the sum of the interior angles of a triangle, minus one of them, pi over 6, and the other one of them we just got 1.10784 ... which is what I got in the calculator right now. So I'm going to equal that to store the answer and do, so I'm going to do 1 over 2 times 3.4 times 1.9 times sine of that angle right there. Yeah? Right? So that's going to be 1/2 times 3.4 times 1.9 times sine of not the answer, but pi minus pi over 6 and minus the answer that I got earlier. So that should be 3.224 ... and 0.406 maybe ... and that is just the 3 significant figures, 3.22. Okay, so question C. Given that, I'm blocking the question here, I think. Okay, I'm just going to move to the right a bit. Given that the ratio of the area of the sector OBC to the area of OBA is 3 to 2. So that means if we want the area of OBC, is going to be equal to 3 over 2, right? Is that? Yeah, 3 over 2 times area of OAB, right? Which is just what we got up here. That's why I need to carry a lot of figures there just to avoid any rounding error, yeah? Okay. So, but the area of OBC, right, which is a sector, is just 1/2 theta squared. Okay? So, times just the figure we got up there, which I have in the calculator right now, so that's no problem. Okay. So we want to find the angle BOC, right? So, which is the theta here. So theta equals 3 over 2 times 3.2246 dot 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 divided by 1/2 down here times R. R would be OB, which is 3.4 squared. If we plug that in the calculator, we get the answer. So I do equal here to store the answer again. And then fraction, 3 over 2. Uh-oh. Okay. Times answer, yeah. 0.5 down here times 3.4 squared. So that is what I got, which is not right. Interesting. Okay. I made a mistake somewhere. Show that the angle BOC is that radian. It seems like I got about 2 times. Wait. The ratio of area of sector OBC is that. So that's 3 over 2. That's right. Yeah. I think I got the area of this guy wrong. Okay. Let me just try this again. 3 over 2 times 3.224. Okay, just that. This is 0.5 times 3.4 squared. Yeah, okay. That's something wrong with my area right here, I think. Okay, let me try calculate the angle here again for question B. So that's pi minus pi over 6. And then minus 1.10784. So this is in radian, 1.5102. And then I substitute that instead. Okay, so let's see if I got the right answer this time. Like a different one. 5.1. Still the same one though. Okay, now I start to think there's something wrong with this one now. So did I do a sine rule wrong here? Size of angle OAB. Okay, so OAB, which is A in this case, I put opposite to that. All right, so that shouldn't be a problem. Sine pi over 6 is 1 over 2, so that multiply and that divide. So let me do arcsine of that again. I'm not sure which one is wrong yet. Yeah. There's something wrong with this. Hang on. So area of triangle OAB is pi over 6. So that's pi over 6. Pi minus pi over 6 minus OAB would be the angle for OBA. And we do sine of that. Yeah, that should be fine. Half AB sine theta. Wait. Yeah, that's right. Yeah, this is still 3.22. Is it this? Show that the angle BOC is 0.462. BOC is the, let me move up a bit. BOC is, wait, what? BOC, yeah, is the angle of the sector. So we have 1/2 pi theta r squared for the area of the sector to the area of a triangle, OAB, which is what we got here. It's 3/2, so I do that. That's why I did that. And then I got this. Okay, this is weird now. Okay, what did I get again? 3/2 times 3.224, and then that's 0.5 times 3.4 squared. I got that again. Okay, I don't know why, guys. Yeah. Okay, I'm just gonna, this is not good. I'm just gonna write this answer right now, the thing I actually got. 0.837. And then I'm gonna just go to do D. Hence find the perimeter of the batch. Okay, so because we're gonna use their value now, 462, right? So the perimeter of the batch is then 1.9 plus OA. We gotta find OA first, all right? So OA over sine of this angle right here. Yeah, 1.5102. I hope this is right though. I mean, this angle right here. But yeah, by the way, let's do that. So, what was it again? Pi over 6 plus 1.5102 plus the other angle is, what was it? Oh, yeah, 1.1078. Yeah, that's about pi. That's right. Okay. So OA over sine that equals, we're just gonna take, I think we're just gonna take 1.9 because it's more definite here. And yeah, so this would be pi over 6. Okay, so OA is equal to 1.9 times sine of 1.5102. Yeah, divided by sine of pi over 6 is 0.5. Yeah, so that's that. And then we add them all up. BC, arc BC is going to be theta r, so theta r. And theta is found to be 0.462 times r is 3.4. 0.462 times 3.4 is 1.5708. And yeah, we're going to find the perimeter now. So perimeter P is going to be equal to, we're going to do the arc length plus 1.9, just go around clockwise there, plus OA, which is 3.793, plus the radius, which is the side OC. That's everything, 4 sides, yeah. So we plus 1.9 here, plus 3.793, plus 3.4. We get 10.6638. Nearest integer, so that's 11 centimeters. We're going to go back to check this later if we have time, but I'm just going to go do question 9 now, which is probably almost the last one, hopefully. A, express that in the form of that. So this is completing square. We just take the minus sign out. Just going to do that. And then x squared here and plus 6x here. Sorry, minus. And then minus 27/4. Okay. That's everything, right? That's right. Yep. Now, because we want this to be a complete square in the bracket, so we introduce another term, which is you divide this by 2, you get 3, and then you square it, you get 9. So I'm doing plus 9 here. But because we introduced this, we got to compensate this. But because there is a minus sign outside the bracket, so if you put a minus sign back into 9, you get a minus 9. The way to compensate minus 9 is the plus 9. And minus 27/4 is still kept. So here we go. This now becomes x minus 3 squared as a complete square here. And well, if you simplify the fractions here, you get 36 minus 27, so that's 9. So I do plus 9/4 instead, right? Yeah, that's fine. Yeah, so this is done. So this is 9/4. ABC are constants, that's fine. Minus 1, x minus 3 to the 2. So here's, we could write A equals 9/4, B equals minus 1, C equals minus 3, right? That's question A done. B, figure 2 shows part of the sketch of the curve C1 with equation that, which is already what we got up here. Okay. Given that the point P is the maximum of point C1. Maximum point on curve C1. State the coordinates of P. Right, so, okay, so this curve C1 is a parabola, is a quadratic function. So the maximum is basically when x equals 3, right? And that's going to give you 9/4, right? So state the coordinates. So x equals 3, y equals 9/4, basically. Okay, that's done. Nice. And then question 4, I'm going to move down a little bit. Yeah, hope you can see. Figure 2 shows a part of the sketch of the curve C2 now is a cosine function, cos kx, where k is a measure, is a constant, and x is measured in radians. Gotta be careful. Given that C1 and C2 intersect on the x-axis, okay, A and B, as shown in figure 2, state the x-coordinate of B. Right, so we need to equate them, solve the equation, basically. I know. We gotta just figure out the cosine function there. The kx doesn't affect. Hang on. So cos kx. So in the normal cos function, we would have. So let me just draw a cos function here a little bit. So this point, if it doesn't have a k there, it would be pi over 2 here. But because there is a k, so it's pi over 2k. Because when you have a k multiplied x like that, you gotta divide the point, right? So divide the x coordinate. And this would have been what? If not the k, this would have been 3 pi over 2. So that would be 3 pi over 2k, right? For the first 2 points that it cuts the x-axis. Now, if we put these into the parabola equation, yeah, we're going to get the x-coordinate. Yeah, I mean, look, we already know the parabola where they cut because you can equate this to 0. So 9/4 minus x minus 3 squared equals 0. So solve for that. I forgot to think about that, sorry. So x minus 3 equals plus or minus square root 9/4 here. I move this on the other side. I get plus minus 3/2 when square rooting it. So I get x equals 3/2 plus 3 and minus 3/2 plus 3. So that would become 9/2 here. Yeah, so 2 multiply 3, get 6, and 6 plus 3 is 9. And this one, 2 multiply 3 is 6. 6 plus minus 3 is 3. Okay. So A and B is that. But we want the B, which is further to the right. So x coordinate of B would be 9 over 2 because it's greater than the other one. Okay, so that's I here. So I, this is part C, yeah. State the value of k. Okay, so we got earlier that this should be 3 pi over 2k equals the x coordinate of b, yeah? And then we have the value of k now, so k equals 2 cancel. So that would be pi over 3, right? Yeah? Right. Just solving that. State the period of C2. So because k is pi over 3, so this is y equals cos. Ooh, interesting. Huh. Wait, hang on. There is a pi value here hanging around. Okay, that's fine, I guess. Why is there pi? Okay. X is in radians. K is a constant. Wait, hang on. I think I need to check the value of k here. Okay, so 9 over 2. Yeah, the x coordinate of the curve there is still 9 over 2. And then 9 over 2, we equate it to this guy. Right? That's the normal cosine function. Okay. Ah, I see. Yeah. Okay, so this is pi over 3x, right? Okay. So the period would be period. So the normal cosine function would have a period of 2 pi. If you multiply the k value there, period would be 2 pi divided, right? So if, for example, if it's 2, then period would be pi instead. If it's pi over 3, we just divide pi over 3 into that. So we get 6, basically. So it's just 6 radian. Yeah, that's the period value. Okay. And the line segment, next one, D now. Line segment L joins P and B. Okay, so I'm just going to have to look at this one. Line segment L join P and B. Okay, so we got to find the area, I guess. The region R1 in the shaded in figure 2 is bounded by L1, C1, C2. Interesting. Use inequality to define R. Okay, so we want inequality here. So it's the area above the curve. So we have y greater than or equal. The cos is above the cos wave. So we have cos pi over 3x here. It's below the quadratic. So y less than equal. The quadratic we got was 9 over 4. And then minus x minus 3 squared there. That's the quadratic we got. And then okay, so if we only had that, then this part would be filled, but we have a little white area here indicating that also the area should be below the line, right? So below the line, we have y less than the straight line joining P and B, which we haven't got yet. So we gotta find, the line joining P and B. Okay, so it's a straight line, I hope. Okay, so we're gonna keep that for later. We gotta find PB first. So P is the maximum. P is, what is P again? I forgot. 3, 9 over 4 up here. And then B, yeah. B was 9 over 2 and 0. Okay, we just want to find the line that passes through these 2 points. So I'm going to do y equals, I'm going to take this as y1 maybe. The gradient, I'm just going to do delta y over delta x right here already. Delta y, that minus that, divided by that minus that. And then here we have x minus x1, which is that. Okay, so we need to find the equation of that first. So the gradient part here is 9 over 4. And this is 6 minus 9 is minus 3 over 2. So 9 over 4 over minus 3 over 2. Okay, so I get minus 3 over 2, right? Yeah, minus 3 over 2. And then if I push everything to the right part, I get y equals minus 3 over 2x. This is plus 9 over 2 and plus 9 over 4. So that becomes 2 times 9 is 18. 18 plus 9 is 27 over 4 here. So we have y below the line. We have that. That should be right. Okay, so these are the answer. Oh, and we're done. We're just the last page here. So that's it, I guess. Let's mark the paper. Oh, but I think I should just go back. I still have some time, about 10 minutes maybe. Although I'm just at 1 hour, but I'm just gonna check this whole question again. Question 8. Can't really be careless about this one. Okay, here we go. So yeah, it says here shows that BOC is just 0.46. All right, so I'm just gonna check my working again. Okay, so I drew that triangle. Find the size of angle OAB. OAB, yeah, OAB is angle A. I have 3.4 over sine A equals 1.9 over sine pi over 6. And then I rearrange. I got 1 over 2 multiplied on the other side. And then minus, okay. And then I add sine. I should get this. I believe in this. Okay. So I think I got that question right. B, find the area of the triangle OAB. So OAB, we got to find one of the angles first. I picked this angle. So I did pi minus pi over 6 minus the angle I got in OAB, which is this angle right here. So this angle was, wait, what? Hang on. This angle was 1.108. Okay, which I use a more precise figure here. Nothing seems off here. I already checked this value. I'm gonna do again, okay? And then, yeah, that's kind of right. Yeah, 8.4. Yeah. So that's that angle, and then I do that to 1 over 2 times the two sides times sine of this angle to get the area of OAB. 3 significant figures. That's fine. And then given that the ratio of the area of the sector OAB, OBC to the area of the triangle OAB. So it's like, yeah, this is right. This equation is right. So OBC per OAB equals 3 over 2. So if you move that, you get this. And the area of OAB we already got from earlier, which is this. Wait, let me find the area of that triangle again. 1 over 2 times 3.4 times 1.9 times sine of 1.5-ish. So that's about 3.22-ish, yeah. Okay. That's weird. Wait, area of a sector OAB. Is that right? I think that's the right equation, right, guys? Yeah, this is right. So 1 over 2 theta r squared. Yeah. So we move it down. We do 3 over 2 times that over 1 over 2 times that. Yeah. Times 3.22406 divided by 0.5 divided by that. Yeah. That's the angle. Sector OBC. So 3.4 must be the radius. That's right. I don't know. I don't see any mistake here. I mean, if you do, you can comment, maybe. Yeah, and if we follow that through for D, we're going to use 0.462. Yeah, we got to use that, although we didn't get question C right, but there you go there. Yeah, I'm guessing I'm going to have to call that. The area of sector OBC to the area of triangle OAB is 3:2. That's right. I have no idea. I don't know if they checked this question already, but there you go. Wait. OAB is greater than pi over 2? We forgot about that, right? Why would it say that? Because, yeah, I think we take note about that before, so B must be less than pi over 3? Oh, no, right. This is about the acute angle when you solve for the arcsine. So OAB must be greater than pi over 2, but that is not greater than pi over 2. Right. Okay. This is acute. So OAB must be pi minus 1.10784. Aha! Here we go. It's 2 points. Just gonna do that first, which is angle OAB's 4 significant figure, 2.033. Okay, so that's A. Right, we should do that. Okay, so this is minus 2.03375 ... Just gonna do 378 maybe. Yeah. Okay, we should redo the whole thing basically. Pi minus pi over 6 and then minus 2.0338. That gives us 0.58419. Okay. When we're going to substitute that in. So I get 0.5 times 3.4 times 1.9 times sine of that. Or let me do 0.58419. Okay. Yeah, now I see. So 1.78, the area of OAB, 3 significant figure, 1.78. Okay. C, so we sub 1.78 in, but I do 4 maybe, 1.781, just to be safe. So 1.781 here. And what do I get here? Hopefully the same answer. Times answer over half times 3.4 squared. Yes, all right. Here we go, guys. We got it. Perseverance in finding the mistake prevails. All right, so we have the theta now, and then we just use that theta down here, so we should be fine. Yep. Okay, so let's mark the paper. I think I'm done. I think this one is fine, right? Let me double check that. All right. So OA, we found it by just doing that over. No. Of course not. This angle changed now. So that would have been 0.58419 instead, right? Is it? Yeah. So OA is opposite to that angle we found right there. So 0.58419. Right? 58419, yeah. And 1.9 here. And okay, so this should change. So that's 1.9 times sine of 0.58419 divided by 0.5, because that's sine pi over 6. Yeah, okay. 2.09579. So we, and the arc here is fine. So the arc, the 1.41, and this is the OA. Yeah. Yeah, so OA should go here. All right. So do it again. 2.09579 plus 3.4, 4 sides already. Okay, so I get less 8.96659 blah 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 equals 9 centimeters. Let's see. Yeah, that kind of makes sense. Should get less. That side is smaller. All right. So that's it, guys. I think I gotta stop there, and I'll mark this later and share you guys later. Okay. See you in the next one. See you in the next one. Okay, so let's mark the paper together. So this is the mark scheme, January 2025 for P1. All right, let's look at the first question right here. Okay, first question is integration. It was, and then I'm gonna use a red color here. Okay, so the first one, wait, where's the first one? That's the fourth question, sorry. Okay, here's the first one. 2x4 minus 4x3 over 2, 1 over 5. That's fine, yeah, okay. Question 2. Okay, so this is root 3 over 9. This is minus 3 root 3x minus 13. So that's fine. So far, so good. This is 33241 for A, and that is for B, and this is 15.9 years. Number 4, a y to the 3, 45a to the 2y over y to the 2. Okay. IIA, so we gotta get the linear equation. I think that's fine. Didn't make that up. So t equals these two numbers. Yeah. So far so good. Number 5, 12x 2 over x squared. That's fine. And then I equate to the gradient, and then I try to derive to this. So that's fine. Wait, I forgot c. Sorry, c. Yeah, k equals 16. Yeah. Okay. All is fine. 6a. Yeah, I got to show, I managed to show that as required, and then I got b to be, well, that's long. Okay, this equation here, 1 over 5x to the 5 over 2, 11 over 6, blah blah blah. That's all correct. This is correct. Okay. 7a, I got the graph, which has the asymptote of y equals x. That's the intercept, so I got all fine there. The inequality, x greater than 18, x less than 2. So I didn't need the greater than 0 there because they have brackets. So I think I'm fine with that. Okay. This one was tricky, I remember. Yeah. Yeah, almost didn't manage to do that. Wait, hang on. Oh, no. Oh, man. I have a rounding error here. All right. This is a silly mistake. Yeah, this should have been 4. Sorry. All right, so I think I lose 1 mark here. Let's see. they probably don't award anything different. Yeah, I'm gonna take my mark off there, 1. So -1 there for this accuracy. And then I got 1.78 here. I got 0.462, and then I got 9 centimeters for the last one. So I'm fine with the others. And then number 9, this is A equals, where's A? B minus 1. Yeah, everything else. Yeah, I think I'm fine with that. 3, 9/4. And then C is 9/2. Wait, yeah, XB is 9/2, K is pi/3, and that is 6 radians. D, okay, see if I got all the inequality right. Greater than cos pi/3x, less than that parabola here. Yeah, this is just the completed square form, which is the same as the 6x minus 27/4 minus x squared here. It's just the original form here, guys. So yeah, I think I'm fine with that. And this one is also the other linear equation that we have to find by this working here. But except I need to check the sign. Do they condone less than or equal? Because I have an equal sign there. I had an equal sign to every part because these are solid lines, right? So that was my logic there. So I'm just gonna see if they allow, right? For D here. Okay. Must consistently use that, or yeah, I think they do. So these, I've seen this kind of like technical issue with the symbols for greater than equal all the time. But whenever you have these weird characters, I think they mean greater than or equal because they can't really do it in a typed document in PDF here. See? So yeah, I think they allow that. So I'm fine with this. So I lost 1 mark. This is then 74 out of 75. And let me actually check the UMS for this, right? If you want to check together with me. So I'm on to the qualifications.pearson, the Pearson website here. And then you can see that I choose International A-Level, January 2025, Mathematics, P1, and then I got 74, so that was 100% UMS. Okay? All right. The only feedback that I would give to this paper is that it was generally okay, but in my opinion, the tricky thing was only this question here, because you got to be careful when you solve for an angle. I think most people will find out that they might have got the wrong angle at first, and then maybe some students will realize that they make a mistake, and then hopefully they find out that this should be the obtuse angle, because don't forget that whenever you do arcsine, you can get 2 values in terms of, so if you have an arcsine of a positive value, you can get an acute or an obtuse angle, right? So beware about that, that you can get 2 answers. Otherwise, I wouldn't have got this, right? But I did make a silly mistake here, a rounding error, right? So that was a bit careless to me. And yeah, this one, I think I've seen some of my students miss this one as well. Like they didn't define this linear equation right here, so they didn't get all the marks for the last part here. And this one was a little tricky as well in terms of the graph and everything. So maybe you want to go back, follow this question again if you didn't get it, right? So I would recommend follow carefully on this one. All right. So that was it. I hope that's helpful, and I'll see you in the next one.